All right, order of operation. Now, let's think about for a second order, okay? Is ordering things always important? Is doing things in a certain order, is it always important? Okay? If you say no, name one thing. Tell me an instance where you could do things in a different order and it wouldn't matter. If you're going to argue no, then you need to have an explanation of why it is no. Now, you could think of probably some random example, and okay, for example, does it matter that you put your socks on before your shoes? Obviously it does. Okay, I mean, you could put your shoes on and then put your socks over it, but at the end of the day, I really wouldn't want to, smell the shoes or the feet. If I could put my boots on today and then I put my socks over my boots, that would look pretty weird. Odd would be weird. But for the most part, when you're doing multiple steps, okay, obviously you want to do them in a certain order. Okay, great example. Imagine if God had created the oceans before He created anything else. Wouldn't really work, would it? Okay, or let's say He created Adam and Eve before He created anything. Okay, or let's say He did this. Let's say that He decided and did. He created the world. Then He created just like He did, but then He decided, I like the world straight up and down instead of tilted. The earth is on an axis that's tilted, and I don't want to tilt it. Well, the problem you got there is if He'd done that, then the earth would either burn up, part of the earth would burn up, part of the earth would freeze to death. Because if you take the earth and tilt it on its axis just 2 degrees, okay, that's 2 degrees, which is about that. You tilt the Earth's axis one way or the other, this way or this way, the Earth would either burn up or it'd freeze, just simply from a 2 to 3 degree shift in the axis. Okay, so all these things that He created, He did in obviously a specific order that was obviously, for what He created, the best order. Okay, if you don't have a rule or a thing to show you, here's what I do first, okay, then obviously you can mess up. Okay, in other words, let's say you're 1 year old. Your parents knew not to give you a T-bone steak when you were 1 year old, okay, and you're barely eating with a spoon, much less, sawing off a piece of meat with a, steak knife, and then trying to, chew or gum it to death, okay, because you really don't have teeth at that point. You're going to, just gumming it to death. Obviously there's a certain order to what we eat, okay. Obviously God has created a sense of, when you're born, you're a baby, and you're not a full-grown adult, okay, like the Benjamin Button movies where you're a full-grown adult, you end up dying when you're a baby. How ironic or stupid that would be. Okay, so everything really in your life you do in certain order. Okay, when you get up in the morning, you do certain things in an order. Well, is that the way everybody does it? Well, not necessarily, but there's a specific order, because if you don't have order, then you have chaos. Okay, just like in our society here, we have rules and regulations we call laws and procedures. Okay, great example, when you're driving. You stop at a stop sign, a 4-way stop sign, and everybody pulls up at the same time. Okay? Well, there's an order that you're supposed to go in that you learn when you study the driving book. The person on the right of you has the right of way. And that's, okay, I'm on the left of you, so I'm going, and you all go together at the same time, then you have, a little collision there. Obviously you're coming out of a stop sign, so it probably wouldn't be too bad of a collision, but unless you just really gunned it and got going real fast. But there's order to everything. Everything in our lives, we have a certain order. Okay, can you imagine if when you started school, you started as a 12th grader? It would? So you want me to go grab the kindergartners and put them in calculus? You know, and what if we had taken you when you were 6 years old and put you in calculus? And then we decided when you're 18, some of you act like this, we put you down in kindergarten. Well, some of you just got that. Some of you just, some of it went over your head, and some of you actually got it. So there's always order to everything. Same thing in math. Okay, there's order when chefs cook a certain meal. There's a certain order they must go in. They're not gonna cook the whatever the meat they're cooking and then put seasoning on it and then marinate it. Then there's certain order to everything that you do, as there is in math. Okay. Obviously, the Lord has given you an order of what you do. Here's how you are saved. Here's how everything that the Lord in your spiritual walk has shown you has a certain order to it. Okay? And order is important. Okay? So the things that we do in our lives are important to do in a certain order. Math, it's very important to have a certain order. Okay? And the order is this for math. Okay? We have PEMDAS. Okay, PEMDAS. Now, PEMDAS is used at a very early age because, realistically, you have parentheses. Realistically, it really should be probably GIMDAS. Okay, because parentheses is not the only thing that you can have that represent what we're talking about. Realistically, parentheses is grouping symbols. Okay. But for our purposes today, we'll talk about parentheses. Okay? The next one is exponents. Okay? The next one is two of them, multiply or divide. I put the word or in there. It's not multiply, then divide. It's multiply or divide, okay? And then the last one is these two here, add or subtract, okay? PEMDAS, and most of you have heard it before, is please excuse my dear Aunt Sally, okay? That's the way that it's an acronym that people can remember, try to remember the steps that you're supposed to take. But realistically, what you've got is this. Step one, didn't want to do that. Step one is grouping symbols. I don't like using the word parentheses because eventually in this class you're going to have more than just parentheses that you're going to have to deal with for order of operation. Grouping symbols is what they're really talking about when they talk about parentheses. Grouping symbols are this: parentheses, brackets, and a fraction bar. Okay, this is a fraction bar. Okay, starting next year, you're going to have a lot of different symbols and of grouping symbols that you will have to use in order of operation. Okay, we'll have some of it this year, but next year it gets into some very extensive stuff. Whether you're in algebra or pre-algebra, next year you're still going to have the same issue. Okay, so you need to understand that it's more than just parentheses. Okay, we can say parentheses now and in your earlier years because that's basically most of what you deal with when you're young. Okay, but for us, we need to start understanding that parentheses means grouping symbols. We do those first. The next one is exponents. Now, when we talk about exponents, we're talking about let's call it this. We're talking about powers and radical signs. Okay, a radical sign is simply a square root sign. Okay, so not only is it talking about exponents, but eventually this year we will talk about problems that have exponents in them and radical signs in them, and we'll have to take and simplify those by order of operation. Okay? And so the next ones are fairly simplistic. They're easy. It's multiply or divide, as I said. Okay? And then number 4 is add or subtract. Now, when you're doing order of operation, you always move from left to right in the expression. Okay, you always move from left to right in the expression. Okay, what most people, when they miss order of operation, is because they start just jumping in the middle and picking out pieces, and they don't do that. Okay. So, for example, if we had this problem, 2 plus 2 divided by 2 times 2 minus 2. Okay. In that problem, well, just do that problem. Everybody do that problem. On your own, do that problem, and let's see something. So you're doing 2 plus 2 divided by 2 times 2 minus 2. All right, who has an answer yet? Okay, just keep working in. Keep working. I'm going to try to get everybody to get an answer. All right, who has an answer? Okay. Drew, what'd you get? 2. Okay. Anybody get anything different? Celine? 0. Okay. Anybody any different? What? 10. Okay. Any different? Don't be afraid if you didn't get one of these answers and you got something different, raise your hand and tell me. The whole point of this. I want to see how many answers we got. Okay. All right. The answer is, let's see. Here, you have to do that first. Okay? We have no grouping symbols. We have no exponents. So we have to multiply or divide first. When you move from left to right in this problem, the first multiplication or division sign that you run into is that. So I have to do that first. Now, here's where some of you will end up making mistakes because you'll do this. Okay, that's 2 divided by 2 is what? 1. And now I'm going to rewrite my problem. Some of you will not do that. Some of you will just try to do it all in your head, and that's, that may work for you for a little bit, but eventually it won't. Okay? Next year, for sure, it won't. Now, as I look at that problem, once again, I have to go from left to right. And I have to see if there's any multiplication or division signs. There is, and it's right there. So I have to do that next. So I have 2 plus 2 minus 2. Okay, once again, Go from the left to the right. Now, there's no more multiplication or division signs, so now I'm dealing with addition or subtraction signs. Okay, well, there is an addition sign right there. And so I've got to do 2 plus 2, which is 4, minus 2. 2. Okay? And so that is how you get 2. Now, a common mistake is you go 2 plus 2, which is 4, then you divide 2 into it. Can't do that. Okay? There are other ways that you could do this problem and still get the same answer. Okay? But this is the proper way to do it. Alright? There are other ways that you could do that problem and still come up with 2. Owen?
In this particular problem, can't you just go from left to right without going in order?
No. You could get the same answer. In other words, if you went here, 2 plus 2 is 4, divided by 2, which is 2, times 2, which is 4, minus 2, which is 2. You get the same answer, but no, you cannot do that. Because all I've got to do is throw a 3 in there and it messes the whole thing up. Then you mess up. Just happens since they're all 2's that you will come up with a 2 there. Doing it that way. Yeah.
But if there was parentheses around 2 plus 2, then you would do that.
Yes, correct. If this was the problem, if the original problem was this, something like that, then yes, you would have to do it first. Or they could even do this. They could do that and put those around it. Okay? Yes, whenever there are parentheses, you always have to do those first, regardless what's inside of it. Let's take, for example, let's say I had this. Let's say I had parentheses 2 plus 4 times 3, close my parentheses, plus 9 minus 2. Let's say I had that. Well, inside the parentheses, I have how many mathematical operations? 2. Okay? So I have to do the parentheses first, but even inside the parentheses, I have to move left to right and do PEMDAS. Okay? So inside the parentheses, what do I have to do first?
4 times 3.
4 times 3. Okay, I have to do that one first. So you have to do this first, and that gives me parentheses 2 plus 12. Plus 9 minus 2. Now I only have one thing left in the parentheses, so that's what I do. 2 plus 12 is what? 14 plus 9 minus 2. Now you just move left to right. 23 minus 2, which is 21. Okay? So you may come across a parentheses that has 4 different mathematical operations in it. If you do, then you still have to follow PEMDAS. You have to do multiplication or division first, add or subtract second. Okay? Inside of parentheses. If there's exponents, you're going to run into some that'll have exponents inside. Okay? So you still have to, inside the parentheses, you have to treat that. You have to treat this part right here like it's a totally separate problem until you finish everything inside. Once you finish everything inside and the parentheses disappear, then you're where you need to be. Okay? All right, now, let me get an actual problem out of the work here. And these problems are not going to be real difficult starting out. Okay, they're fairly simplistic. In fact, let's do this. Everybody turn to page 21. Turn to page 21. I want you to do, on page 21, I want you to do problem 16 and problem 22. Problem 16 and problem 22. Let's see here. Yeah, well, yeah, just go ahead and take it. There you go. do problem 16 and problem 22. Hopefully our those that are getting new books, you'll get them probably on Wednesday of next week. Hopefully they'll be in. So we're doing number 16 and problem number 22. Write the original problem, show your work, and circle your answer. Okay, don't just put down an answer. Because when you get home tonight and you're looking at your notes, you're going, well, how did I come up with that? You may not remember what you did. Okay, or you may remember 2 or 3 things that you might have done. That's why it's always good to write the original problem, show all your work, and then write your answer. Plus, the bottom line is, if you miss it and you don't have your work shown, then I don't have any way to help you. Okay, so your 2 problems, if you're still working, keep working on it. Your 2 problems are 40 minus 12 divided by 6. That's problem number 16. Problem number 22 is 8 minus 2, the whole thing raised to the 2nd power, plus 12 divided by 6. Okay, so let's look at 16. The first thing that we have to do at 16 is the division. So I have to do the 12 divided by 6. So that gives me 40 minus 12 divided by 6 is what? 2. So 40 minus 2, 38. Okay, fairly simplistic. Okay, it's just try to get you to think through the steps. 22, 8 minus 2, the whole thing raised to the power of 2 plus 12 divided by 6. So I have to do the parentheses first. So inside the parentheses, I have to do that first. 8 minus 2. Okay? 8 minus 2 is what? 6. Now, that's the new problem that you have. Okay? Please excuse my dear Aunt Sally. Parentheses, then exponents, then multiply or divide, then add or subtract. So what do I have to do next? Exponent. And that is 6 times 6, which is 36, plus 12 divided by 6. So now, 36 plus 12 divided by 6, what do I do next? 12 divided by 6. You have to do that next, which gives me 36 plus 2. And look, lo and behold, both of them are the same. Okay? So, like I said, not real difficult. Okay? Everybody look at number 25. 25 has x plus y over x, where x is equal to 3 and y is equal to 6. And eventually, and z equal 2. Okay, we're obviously not using z in this one, but Eventually you will in some of the other problems. So, somebody tell me what my expression would be then. They tell you to evaluate for the values of x equal 3, y equal 6. So what's my new expression when I use the substitution principle? What's my new expression going to be? Nick?
3 plus 6 over 3.
Okay, 3 plus 6 over 3. Okay, we already talked about this as a grouping symbol. A fraction bar is a grouping symbol. Okay, so I either have to do everything that's on top first or everything that's on bottom first. Well, is there anything on bottom that I can do? No. So I have to do what's on top first. And what is 3 plus 6? 9 over 3. That's just a division problem. 9 over 3, you can reduce it down, you can divide it, whatever you need to do. But what is 9 over 3? 3 over 1, but 3 over 1 is not simplified. No, 3 over 1. 3 over 1 is what? 3. It is 3. 3 over 1. How many times does 1 go into 3? 3 times. Okay? Y'all are thinking like 5 over 2 or 6 over 2 or something like that. Okay? So the answer is 3 to that problem. All right? Now, I am going to go ahead and turn you loose on your homework. Still got about 20 minutes left in class. Your homework is going to be 1.4. Six through 33. Okay. Remember, write the original problem. You do not have to write word problems. Okay. If it's a word problem, you do not have to write it.